Today's video covers static electricity, which refers to the buildup of electrical charge on insulating materials, and this buildup can eventually cause visible sparks when discharged. Now, every material around us contains electric charges because their atoms are made up of positive protons and negative electrons, but under normal conditions, these positive and negative charges are present in equal amounts, cancelling each other out and keeping most materials electrically neutral. However, when two insulating materials are physically rubbed against each other, like when a plastic bag brushes against a woolly hat, the friction between their surfaces transfers electrons from one material to the other. In conductive materials like metals, electrons are free to move and flow back easily, so even if some disturbance happens, no significant charge accumulation occurs because the electrons instantly redistribute themselves. But insulating materials, like a polythene rod and a cloth, don't allow this easy movement of electrons. So when friction occurs, electrons are forcibly transferred in one direction and then get trapped, leading to a buildup of charge. The material losing electrons ends up with a positive static charge, like the cloth, while the material gaining the electrons becomes negatively charged, like the polythene rod in this example. The specific behavior of electron transfer actually depends on the exact materials in contact. For example, if we rub the same cloth on an acetate rod instead of a polythene one, the electrons would instead be rubbed off the acetate rod and move onto the cloth, leaving the acetate rod positively charged and the cloth negatively charged. But regardless of the materials involved, the crucial thing to remember is that only negative electrons are transferred during these interactions. Positive static charges happen purely because a material has lost negative electrons, not because it somehow gained positive protons. Now, if an object keeps accumulating negative electrons without discharging, the amount of stored charge increases, and as it builds up, a potential difference gradually forms between the charged object and the Earth, or anything connected to Earth like a human body, since Earth is always considered to be at 0 volts. If this potential difference becomes large enough, the electrons can suddenly jump through the air across the gap between the object and the Earth, and this sudden movement of charge creates a spark, which is just a quick flash of electrical discharge. It's important to mention that although static charge is mainly associated with insulators, under certain conditions, even conductors can build up charge. For instance, when a car travels at high speed, the metal body of the car can accumulate charge due to friction with air particles, and if you touch the metal after the journey, you might feel a sharp shock. This is simply a small spark discharging from the car through your body to the ground. Anyway, that's everything for today's video. So if you found it helpful, then please do give us a like, share it with your friends, and don't forget to subscribe. We'll see you next time.